A very good afternoon to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering from Institute of Aeronautical Engineering. And I'll be dealing the subject robotics, and my today's topic is definition and terminology from Module 2, that is motion analysis. Right? The Module 2 is about the motion analysis, and in this particular module, we will be studying about the definition and terminologies, right? Coming to the first one, what is rotational matrix? What do we mean by the term rotation matrix, right? Here, the rotational matrix describes the mutual orientation between two coordinate frames. For example, if we have two coordinate frames, right? This is one link, this is the other link, and this is the end effector, right? So when we have to when we need to find out the mutual orientation between two coordinates, right, that will be determined by rotational matrix. That is, the rotation matrix describes the mutual orientation between the two coordinate frames, whether it may be in column vector, are the directional cosines of the axis of the rotated frame with respect to the original frame. That is, for example, when we are taking this particular type of the axis, right, and we are considering three axes x, y, and z, right, which is moving at an angle theta, this is moving at an angle alpha, this is moving at an angle psi. So, all this is equal to 0, z is equal to 0. For axis x and y, we will be writing a rotational matrix as cos theta, sin theta, 0, sin theta, cos theta, 0, 0, 0, 1. So, this is how we write the rotational matrix for any axis which is having two coordinate frames. Right? This is how we write the rotational matrix for any particular robot which is having two coordinate frames. That is, its column vectors are the direction which has cosine of the axis, of the rotated frame with respect to the original frame. Right? It represents the coordinate transformation between the coordinates of a point expressed in two different frames. Right? That is known as the rotational matrix, and we write the rotational matrix for any particular two quadrants as cos theta, sin theta, 0, sin theta, cos theta, 0, or 0, 0, and 1. Right? Next. Moving on to the next one, define kinematics of robo. What do we mean by kinematics of robo? Kinematics of robo means which is generally used or prescribed to determine the motion of the robot, right? So here the kinematics is used to determine the motion of the body in a robotic mechanism without regard to the forces, without regard to the force or the torque, right? The kinematics is used to determine the motion of the body where the robotic mechanism without the respect of the force or the torque caused in the motion. That is known as the kinematics of robot. So here, when we consider this particular type of the robot mechanism are by their very essence design of the motion. Right? This particularly is based on the mechanism of the very essence design for its particular motion. Right? That is known as kinematics of the robot. Next, moving on to the next one. Define workspace and work envelope. What do we mean by workspace and what do we mean by work envelope? Generally, workspace is used to determine the geometry of the manipulator. Right? Generally, the workspace is used to determine the geometry of the robotics. That is, it is used where the robot manipulator has total volume swept out by the end effector as the manipulator executed all possible motions. When the manipulator executes all the possible motions, right, this particular workspace comes into account, or we also call it as the work environment. It is most generally the workspace of a robot manipulator is nothing but the total volume swept out by the end effector as the manipulator executes all the possible motions. That is known as the workforce or the workspace, right? And the workspace is used to determine, it's been determined by the geometry of the manipulator, right? Next, moving on to the next topic, describe the forward kinematics. What do we mean by forward kinematics? The forward kinematics of a manipulator is to find the position and the orientation of the end effector. If we are having any particular type of the end effector, right, the forward kinematics is used to find out the position as well as the orientation of the end effector. Right, the forward kinematics of a manipulator is used to find out the position and orientation of the end effector based on the given position of all the joints and the values of all the geometric link parameters. That is known as the forward kinematics. Next, inverse kinematics means what? Right, this also gives the values of the joint position given the position and orientation of end effector relative to the base and the values of all the geometric link parameters, that is, which is moving in a reverse direction. Any particular robot manipulator, when it is moving in the reverse direction, it is known as the reverse kinematics. Right? Any particular robot's manipulator which is moving in the reverse direction is known as the inverse kinematics. That is, the inverse kinematics manipulator is used to find the values of the joint positions given the position and the orientation of the end effector relative to the particular base, the base of the robot, and the values of all the geometric link parameters is known as the inverse kinematics. Right? Next, moving on to the DH notation on the parameters. Define DH notation or the parameter. What do we mean by DH notation or parameter? Generally, DH parameter was introduced in the year 1955. Right? DH parameter was introduced in the year 1955. What do we mean by DN? Denavit and Hettenberg. Right? Denavit and Hettenberg parameter was first been introduced in the year 1955 to represent a direct line which is nothing but the axis of a lower pair joint, right, which is used to direct the line which is nothing but the axis of the lower pair joint. That is, in order to represent this particular parameter, it was being determined, since it was being introduced by the scientist called Denavit and Hettenberg, it is being named under their name, that is known as the DH notation or the DH parameter. Right? Next, moving on to the next question. What is the world coordinate system? World coordinate system means what? This particular type of the system is nothing but the coordinate system whose origin is specified by a user. Right? That is, any particular origin which is being specified by a certain user. Right? Any particular origin which is being specified by a certain user is known as the world coordinate system. Now, this particular type of the system enables multiple robots to use, right? So, this particular system is using multiple robots like M1, M2, M3 and M4 and so on. This particular type of the system uses multiple robots to use as a common coordinate system. As I've told you, the user will be common coordinate system, and according to this particular user, will have multiple access to the robot. Right? So, by setting the origin of the facilitates to that of the world coordinate system, we can set the position of different robots on the same coordinate system. Right? We can set the position of different robots on the same coordinate system. That is known as the world coordinate system. Next, moving on to the next one. What is joint coordinate system? What do we mean by the joint coordinate system? Right? Generally, the joint coordinate system is which is representing at its particular joint. Which is representing at its particular joint J1, J2, J3 and all. Right? So any particular system which specifies the location of each axis in encoder counts, that is known as a joint coordinate system. That is, a joint coordinate specifies the location of each axis in the encoder counts. When this particular axis moves, the optical encoder generates a series of alternating high and low electrical signals. When this particular axis is moving, that is, it has an encoder, right? So when this particular encoder is some are shaded and some are not shaded. So when these particular encoders are moving its particular axis, right, it generates a series of alternate voltage signals like high and low signals. Like it is generating a high and low signal. Right, so that is known as the joint coordinate system. So here the number of signals is proportional to the amount of the axis motion. Right, the number of signals is equal to the amount to the axis of motion, where the controller counts the signal and determines to show. Where the controller is controlling this, counts this particular signals and determines the show. Right. Next, define DC servo motor. What do we mean by DC servo motor? DC servo motor means direct control servo motor, right, or direct current servo motor. So here, the motor which is using a DC servo motor generally have a separate DC source, right? Any particular robo which is using a separate DC source is being determined as a DC servo motor in the field of winding and armature winding. In the field of windings, right? Now, the control can be achieved either by controlling the armature current or with the help of the field current, right? The control can be done either with the armature or it can also be done with the field current. That is known as a DC servo motor. It is a motor which is used as a DC servo motor, generally having a separate DC source in the field of windings. And the control can be achieved either by controlling the armature current or the field current. Next, what do we mean by the stepped motor? Stepped motor, generally where do we use this particular stepped motor? Here, other than the hydraulic motor and other than the pneumatic motors, that the robot which is using the DC motor, that is a stepped motor, is just another digital device, or more precisely a digital DC motor, that is stepped or the stepped motor, which allows you to select certain constraints. Right? That is known as a stepped motor. That is generally when this particular type of the motors are used in electrical, where the robots are being manufactured in the form of electrical constraints. There we use this particular type of the stepped motor. That is, where it uses the digital devices which has more precision and a digital DC motor. Right? Next, what do we mean by position sensor? Position sensor means what? Position sensor is a device that permits position measure. That is, at which position the robot is at. Is been determined with the help of the position sensor. It can either be an absolute position sensor or a relative one position sensor, can be a linear, angular or a multi-axis. The position sensor can be a linear, angular or a multi-axis type of the position sensor. Right? A position sensor is a device which is used to permit the position measurement, right? Where it can either be a absolute position sensor or it can either be a relative one position sensor, which determines whether the particular robot's end effector is in the linear direction or it is in the angular direction, or it is in the multi-axial direction. So that is known as the position sensor. Next, define resolver. What do we mean by the term resolver? A resolver is a type of the rotary electric transformer used for measuring degrees of rotation. When we need to find out the degree of rotation of the robot manipulator, we will be doing it with the help of the resolver, right? When we need to find out the degrees of rotation of the robot's manipulator, the resolver is used to find out the rotary electric transformer in terms of degrees of motion. Next, what is potentiometric sensor? What do we mean by potentiometric sensor? Potentiometric sensor means what? A potentiometric sensor is a type of the chemical sensor, right? A potentiometric sensor is a type of the chemical sensor that may be used to determine the analytical concentration of some components of the analyzed gas or the solution. These sensors measure the electric potential of a electrode when no voltage is present. When there is no voltage, this particular type of the sensors are being used. The potentiometric sensor is a type of a chemical sensor that may be used to determine the analytical concentration of the components for any particular solution. These sensors are used to measure the electrical potential of the electrode when there is no voltage present. Right? Next one, define encoder. What do we mean by the term encoder? What does encoder mean? An encoder is a device or it is a circuit, right? An encoder is a device or it is a circuit or it is a transducer or a software programming which is used to convert the information from one format to the other. An encoder is a device which is used to transform the information of the robot's data from one type of format to the other for the purpose of standardization of the speed or compressor. So this particular data may be in the form of the device, or it may be in the form of circuit, or it may be in the form of software programming, or it can be in the form of algorithm. Whatever is the type of the technique this particular robot is being using, that technique is being converted from one form to the another form in the form of a standardized speed or compression. That is known as an encoder. Next, what is velocity sensor? What do we mean by velocity sensor? It is a sensor which is used to measure the position measurement known as intervals and computes to the time rate of change in the position values. Right? A velocity or a speed sensor is used to measure the consecutive position measurement at a known intervals and computes the time rate of change in the position values. Right? Next, define workspace or work environment. We have already discussed this. That is, most generally, the workspace of a robot manipulator is nothing but the total volume swept out by the end effector as the manipulator, or it is used to determine the geometry of the manipulator is known as the workspace. And what do we mean by forward kinetics, which is used to determine the motion of the forward motion of the robot, or inverse kinematics, which is used to determine the reverse motion of the kinematics with respect to its end effector's position and the orientation. Right, that is based on the values of all of the geometric link parameters, the inverse kinematics will be determined, or we can also tell it as a reverse kinematics. Right? These are the references which we have gone through. So in today's class, we have learnt about the definition and terminology of rotation matrix, kinematics of the robot, the inverse kinematics, DH parameter and rotation. What do we mean by the term world coordinate system? And what do we mean by joint coordinate system? And how do we define a DC servo motor? We have seen. And what we mean by a stepped motor? What is a position sensor? What do we mean by a resolver? What is a potentiometric sensor? And how do we define encoder? And what is the velocity encoder? And what do we mean by workspace and forward kinematics and the inverse kinematics? All this we have learned in today's class. I hope you all have understood. And these points will give you a very brief description about the concepts in the module 2 about the motion analysis. Right? So hope you have understood. Signing off for today, Dr. G. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.